Hello community! A lot of you ask me, hey, how do you learn new topics? Well, now you can watch in real time. So I'm interested in my new topic. I want to make a video about vision transformer. So should be a YouTube video. So I go to YouTube and I have a look. What are the vision transformer videos already available? And you see here, for example, by Yannick Kilcher, that about, I think it was 2 years ago, there was the first video on this topic. And as always, the first videos are a paper explained. So here we have, if we go there, a beautiful description of the paper, and you can see a lot of scribble. So he is fighting with the first research paper. And then you have here on the right-hand side firm recommendations that Google tells you, hey, have a look at this one. So you have attention is all you need. You have vision transformer for image classification, end-to-end object detections, and so it goes on. So as always, I start with the first scientific paper. So let's have a look at this. And here is it. Published, and an image is worth 16 times 16 words. Transformer for image recognition. So we go for vision transformers. And you're not surprised, it's by Google Research. Well, they had something to do with the design of transformers in general. They came up with the transformer architecture. And after NLP, now I want to make a new video about transformers for image recognition in 2023. Almost 2 years ago. So what have we learned? What is new? So I have to read the first paper. They say the first transformer architecture has become de facto standard for natural language processing tasks. Its application to computer vision remained limited. This is June 21. And they say we show that the convolution is not necessary and a pure transformer applied directly to image sequences or image patches can perform very well on image classification tasks. So vision transformers attains excellent results compared to state-of-the-art convolution networks while requiring substantially fewer computational resources to train. Okay, so we have here a quarrel between here our established CNN, our convolutional neural network, and now the new vision transformer. This was 2 years ago. And you might say, okay, this is great. So what happened? Tell me about vision transformer. So I have to read this paper. And the nice thing is it is just about 10 pages. You see, we have here our transformer encoder with the different layers, X layers. And this is exactly what we know from NLP. You can see here that they cut the pictures in different image patches. We have a linear projection, we have our transformer, and we have a classification head for a particular class. So the idea is clear. Since we have had a deep dive in the language transformer, now the vision transformer has a very similar infrastructure, coding infrastructure, a coding design. This looks interesting. I have to read this. Hybrid fine-tuning and higher resolution, setup, model variance, fine-tuning, the metric, downstream task, comparison to state-of-the-art in 2021, so 2 years ago. Beautiful. So you see here, okay, here are the benchmarks, scaling studies, beautiful. Inspecting vision transformers that you see here, where the attention is really focused on the object. We want to identify, to segment self-supervision, beautiful. Linear embedding, conclusion, beautiful. So after 9 pages of the original paper, this is the first step I normally do. And then, and you're not gonna believe it, I go back to YouTube and I have a look here if there's something available from Stanford, from MIT, from Berkeley, from whatever, Harvard University, whatever you like. And normally they have courses, and you can see here. This is 6 months ago. They have now a Stanford seminar on Transformer United and deep learning models that have revolutionized natural language processing, vision, and reinforcement learning. Computer vision reinforcement learning. Beautiful, beautiful. And you have here 10 videos. So these are the next 10 videos. Normally I would watch here from Stanford. And then I would go here directly on the homepage and I see, okay, winter 2023, we have CS25 Transformer United version 2 coming up. And there's a new course at Stanford University. And I say, okay, this is the resources. If I really want to have a scientific deep dive, I would have a look at this and look at January 10th. This is tomorrow. For me, it is now January 9 evening. So tomorrow they would start with this particular class, CS25. The nice thing is their last lecture that you have here, the Fall 21 website is online, and the Fall 21 recordings of the lectures are available publicly, freely available. So beautiful, I go there if I want to have some materials. I know Chris Manning from his publications, very nice thing. This is something I like. Transformer, yes, yes, yes. Recommended readings. Recommended readings. I see how it is structured. Switch transformers. Okay. Self-attention mechanisms. Data point. Okay. Yes, yes, yes. I get an idea about it. This is great. And yeah, as I told you, here are my 10 videos. Great. And if you want, please. No, this was the wrong one. This was the wrong one. Where's the actual one? Here. Please inscribe if you can, or I don't know if it's free, or whenever this page becomes available, the recordings become available. Have a look at this. You see at January 17 in 1 week, they have somebody from OpenAI talking about ChatGPT, InstructGPT, and GPT-3 in general. So really nice information. This is another source of information if I want to become familiar with a topic. If I want to make a video, I have a look at the information available. But now you want to say, okay, we are talking about transformers. Of course, I go to HuggingFace transformers. So HuggingFace transformers. And here I have, oh, wait a minute, I have my text models. No, I'm now in the vision models, as you can see. Let's make it a little bit bigger. Vision models, great. And now I can see, oh yeah, wow, this sounds interesting to me. And you have, wherever you go, an overview. This is the first paper, and you have here an abstract from the paper, and you have an idea what it is. Applies transformer encoder and decoder architecture to object detection. Okay, this is nice. But you know, we are here. One of the competitor, as I told you, is CNN or ResNet is here a very famous model. Let's put this in this way. So again, we go to the overview. We have here the original paper. Yes, yes, yes. You see here our implementation follow the implementation by NVIDIA. Yes, yes, yes. It is called ResNet, and important milestone. ResNet won 2015 competition. So you have an idea where you are in the time frame. And then you have an abstract from the paper, residual learning framework, substantially deeper. Yes, yes, yes. Beautiful. And you have normally some short information. The original paper, the configuration, the code. You have the model, image classification. Sounds very familiar. But of course you have here swing transformers. If you want to have a look at this, this is very easy. This is just using shifted windows. And if you have a look here at the abstract, I just read it some minutes ago. A new vision transformer called swing transformer serves as a general backbone for computer vision. Challenges in adapting from language to vision arise from differences between the two domains. Yes, yes, yes. And they have more or less a shifting window. Beautiful. And output, yes, the backbone, yes, yes, yes. What's nice, you have here the original paper. And if you want to see the code, normally you have the original code can be found here. So you have also the code implementation, and here you can jump right into the class definitions. Now, we are interested, as I told you, into the vision transformer. So let's go vision transformer, ViT. So I look here on the right-hand side, I have my vision transformer overview, the configuration file, feature extractor, the vision transformer model itself. Then I have the pre-training exactly as in NLP. I have my ViT for mask image modeling. Then I have my fine-tuning for not for sequence or for text classification or token classification, but now I have image classification. And then, of course, I have here the TensorFlow implementation and the JAX flags implementation with TPUs. So everything here for PyTorch, TensorFlow, and JAX. Great. So vision transformers. Now I learn about vision transformers. So again, I have here the original paper. This is always, it starts with a preprint on Arxiv somewhere, and I can see, and then there's the abstract of the paper. We just went through this. And then this is nice. Then sometimes they have tips and they tell you what they have learned since the first paper came out. So this is great. So have a look at this demo notebooks regarding inference as well as fine-tuning vision transformers on custom data can be found here. So this is where I jump in and say, okay, let's have a look here. Where are we? We are in a GitHub repository. Niels Roger, I know him. Yes, great, HuggingFace. So he gives us here and the README 3 notebooks. Directory concerns several notebooks and illustrate how to use Google Vision Transformers both for fine-tuning on custom data as well as inference. Includes the following notebooks: Performance Inference with Vision Transformer to illustrate image classification, then fine-tuning on the HuggingFace trainer, and fine-tuning now on PyTorch Lightning. Great. So wherever we are, what is the first one? No Lightning. No, I want to have the HuggingFace trainer. Here we go. And then I have here my notebook, and I can open it directly in COLAB. And this is sometimes when I show you my COLAB notebooks and I tell you this is an official COLAB notebook. We execute on this together. How satisfied are you? I'm very satisfied. I love it. Academia, yes, thank you for your input. Thank you too. Beautiful. See you, Google. And then you just go, you sign in, and you can execute this notebook. So this is the way I normally learn about new topics. Fine-tuning, vision transformer, great. Now, if you say, okay, vision transformer, there are quite a lot of models. So what happened since the publication of the very first model? And you know, vision transformer, the very first model was exactly an image worth 16 words. This is where we started. Just hold on a sec. This is the original publication where the topic started. And then if you want to frustrate yourself and if you think that you understand everything, then you go to my beloved papers with code. And this is really only for professionals and really if you want to learn, if you are a scientist. Otherwise, think twice if you want to enter this rabbit hole here with me. So normally I look at methods and you see here, very meta, you have some general topics that are trending. For example, attention, the attention mechanism. You see alone with attention, we have 120 methods and there are 20,000 papers with code available just on attention. On the attention mechanism, we have 11,000 papers with code. Activation function, 53 different methods for activation function. We have 25,000 papers with code for activation. Okay, so these are the general topics and you have 129 further categories, but we look at the main chunks. So the next one is computer vision and speech, of course. So computer vision, and you see still here, convolutional neural networks, our CNNs, like ResNet, is still here a dominant topic. 118 methods with 5,000 papers. Generative image model blocks, object detection models, image feature extraction, and further 122 categories. Beautiful. Then we go NLP, language models, then immediately you see transformers. 88 different methods for transformers and 11,000 papers with code on transformers. Heaven's sake, and this just in NLP. Then of course we go our old-fashioned word embeddings, beautiful non-contextualized vector embeddings of our words. Then again, attention, and then sentence embeddings. Yes, 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 S-bird, yippee! What else we have? The next one is audio. So we have vision, speech, audio, and then we have reinforcement learning. And reinforcement learning, especially policy gradient methods, remember, we are here in this January 2023. we know that ChatGPT was hyping not so long ago, and they had here GPT 3.5 plus some reinforcement learning from human feedback, and they developed their own policy methodology, PPO, here in this topic, and then you can go on with distributed reinforcement learning and reinforcement learning frameworks. Beautiful, interesting topic, audio interesting topic. Then you have here sequential modes, sequence to sequence model, time series analysis, beautiful. And of course, the last big chunk is graphs. Graph model, graph embedding, graph representation learning, and data augmentation. But as you can see here, then I make a deep dive. And normally, if we're in computer vision, I would jump here into my 122 categories, and I try to learn what happened in the meantime. And as you can see, I started about an hour ago. This here is my treasure chest that I found. And I go now here with papers with code to computer vision. And I say, okay, browse state of the art, computer vision. And I see here on one piece, I have 3,000 benchmark, 1,000 tasks, and 30,000 papers with code. So if you want to be frustrated, welcome. This is your place. And then again, we have 3D segmentation, image classification, recommender system, face verification, whatever, representational learning. We have word embeddings, graph representation learning, image classification, semantic segmentation, object detection, 2D classification, domain adaptation, image generation, data augmentation, super resolution, meta learning, autonomous vehicles. And then I just give you an idea about the topics. Yes, 30,000 papers you have on computer vision. So whatever you think that you know, let me tell you, there are at least 1,000 papers on the topic you have no idea existed and people analyzed before you. So great. So when we are frustrated enough, we go back and say, okay, let's focus more. We go now on vision transformers. And here, papers with code, I highly recommend this. This shows me again a summary, but now in a time series. Have a look at this. I have now my topic. My topic is I want to make a video on vision transformers 2023. So you see, first paper again, 16 times 16 words. Vision transformer gives me a short intro. Image classification that employs transformer-like architecture over patches of an image. An image is split into fixed size patches. Embedded position embeddings are added, and the resulting sequence is fed to a standard transformer encoder stack. Beautiful. Isn't that beautiful? You can read the paper, you can see the original code. But then, and this is what I like, just wait a second. No, this was the wrong one. So, and then I look here in the paper section, and this is where I really start to cry. Because now you see, this is, it happened here with this paper. As I showed you here, first paper, June 21. And now, let's see how many papers we have. And I ordered it that I see the most actual first and have augmented segmentation of medical images. Dino, really interesting topic. Efficient distributed training of vision transformer foundation model in medical domain using or through mask sampling. A new publication, January 5th, 2023. January 3rd, an empirical study, pre-trained models, navigation, online distillation, vision transformers, and wherever you have our little GitHub, we have the code available. And you see, you can go back day by day, and you see here a total of 587 papers that originated, that were initialized by our first scientific paper on vision transformer. Of course, transformer from Google and vision transformer also initiated by Google. Now, you can have here a deep dive. Either you go here for the number of stars, you can sort it what is trending, and you see here the number of stars. You can go down and get an idea what people are reading. You can see here almost 2022, 2022, 2022. Okay. Object localization, yes. Multimodal supervised learning, yes. Transformer backbone, object detection. Within a vision transformer, you have so many tasks, but I'll show you in a second when we go on. What I want to show you here, task. This is a very nice presentation. I always look at this. It gives you what are the subtopics here in our vision transformer. Let's have a look at this. You see here immediately, the biggest one is image classification. Means, is this a dog on the picture? Is it a cat? Is it a building? Is it a human? Beautiful. Next one, semantic segmentation. Next one, object detection within an image. Self-supervised learning, instant segmentation, domain adaptation, and a lot of others. But the nice thing, you have here the number of papers per subtopic or per task, and the share from the general. So you see here beautiful image classification, 100 papers with vision transformer architecture. And then if I click here, for example, I want to make a video on vision transformers on the task of image classification, I can choose now of 2,824 papers with code, 147 benchmark datasets and benchmarks and 199 datasets. So, and it gives me a short introduction. Image classification, a fundamental task that attempts to comprehend an entire image as a whole. The goal is to classify the image by assigning it to a specific label. Cat, dog, human, mountain, sky. Beautiful. And then you have the benchmarks, yes. You have the libraries, you have the code, you have the paper, you have the data set, you have the subtask, and then you have the most implemented papers. And this is so nice. Here you really have the paper and the code, and you're not gonna believe it because the whole page is called Papers with Code. So we are now computer vision, image classification, and here we are now here. You can read the paper from 2016. So it is image recognition in general and the code implementation. So you can have a deep dive, unbelievable, I tell you. But let's go back. So semantic segmentation. This is clearly what it is. Semantic segmentation or image segmentation is the task of clustering parts of an image together which belong to the same object class. Sofa, a little table, the wall, TV, light, whatever this is. Beautiful. You have here your leaderboards, your data set, your libraries, whatever you can, your subtask. And again, here we go with implemented paper, UNet, hey, yes, biomedical image segmentation. You see 2015, 2016, 2019, 2018, beautiful. What else? This is nice. This shows you the change. You see here in red, ResNet. This is one of the most dominant models I can remember. You see here, 2017, it starts. Beautiful, it goes up here, up. It is absolute dominant here. 2019, 2020, 2021, 2022. But beginning 2023, you see here the blue takes over. And the blue, and you're not going to believe it, is Vision Transformer. So you see here, you have a paradigm shift. When more or less the number of papers that are published, the preprints, sorry, not the papers, the papers and preprints that are published on a preprint server, academic preprint server, you see when a model has its peak and when a model comes down and another technology comes up. And I don't need to know a lot of, but I know that Vision Transformer, so the transformer architecture in Vision, is now starting to take off, and ResNet had its time beautifully. And then I can make a deep dive and I can look at studies to compare those two technologies in detail. So you see, great usage over time. I get here my next ideas on which topic I will focus, what I will tell my viewers. what I can recommend my viewers. But please use it yourself. It is amazing, the information we have available. Next point, where are we? You say, yeah, come on, give me more. Yes, of course. Components. What we have our dense layer network, our feed-forward network within a BERT layer, within a transformer layer, an encoder stack. In each encoder, we have normalization, of course. We have multi-head attention in each BERT layer. We have residual connection, and of course, we have the attention mechanism, the self-attention mechanism, the dot product attention mechanism. I have a specific video on this, and you see here the components that you have to get yourself familiar with. If I want to do a video on a specific topic, I see here what I do not know, where I have to learn what is it. And if I go, for example, here in the scale dot product attention, I have here again the paper. Attention is all I need. My goodness, this is everywhere. It shows you the attention formula, shows you the graph. You have the paper, you have the code. And then you can say, okay, and all the papers related to this, and no, don't do it now. Please do not do this. And you see even January 5, 2023, beautiful. But you see now it's coming on to medical. This is so great to see now the real world application. But I think this is it for a first overview, how I prepare my resources, how I start to investigate my topics. I have here kind of a directory of my HTTPS links that I find interesting. I try to have a university. I have the original paper. I go to HuggingFace. I have a look at the definitions, at the code available. What is the best code available? I have a look at YouTube videos. I see what is trending, what people are preparing. They always start with a scientific paper analysis and they start. But I'm now more or less to say 1.5 years after the paper was released. So I have to look, hey, what are the trending topics, what we learned since the research paper was released, and what can I provide content to my viewers on my YouTube channel. So I hope I helped you a little bit to give you a little bit of guidance if you want to approach your artificial intelligence, if you want to approach how to code, how to inform yourself about the theory in computer vision, in natural language processing for medical application, the methodology, if you have time series, if you have graphs, data structured, what you can do. There's an amazing amount of information out there on semantic segmentation, 3,500 papers. No way I can have a look at this, so I have to prioritize papers. I have to focus my attention. And then I have a deep dive and it takes some days. And then when I merge, I come up with a new video. And I hope it showed you how I prepare my videos, how I do the research, how I learn. There's a lot of learning on my side whenever I do a video. And whatever I can see what is already there and how I can build up on other videos and present some unique content to you. My goodness, this was a long video. I hope you enjoyed it a little bit. You got some information. You are fascinated. You want to go out there. You say, okay, show me papers with code. I have a question. I never had an answer. Here you will find your answers. I say thank you for watching. Thank you for listening. And I see you in my next video.